So I'm at Willamette Mission State Park, just a few miles north of Kaiser. And I got to show you something. I don't know if you're familiar with this, but I want to show you something. It's not this tree, it's another tree. Maybe you know about this. It's black cottonwood. I think you might be amazed. It's just a little ways up here. You can see the very top of it up here. I can't capture it very well on this camera, on my phone. There you can start to see it through there. I'll come back a bit. Look at this. Look at this. This is amazing. This is huge. Let's go take a look at that plaque. Look at the size of this. Circumference, 26 feet 3 inches. Height, 155 feet. Approximate age, 215 years. This tree is the largest in the nation. Now, a number of years ago, I ended up buying about 40 acres of clear-cut land, and I had to replant it. It started to change the way I thought about trees. So I look at this tree, and I'm seeing that this has a lot of potential. Now look at this, a height of 155 feet and a massive 26-foot circumference. This tree is an absolute gold mine. Now just think about the sheer volume of material we're dealing with here. Now, let's see. What would we be looking at as far as board feet here? Well, we need the diameter. We've got the circumference, but the diameter is the circumference divided by pi. Well, the circumference is 26 feet divided by pi, 3.14. We're looking at around about 8 feet. So, we want to estimate the volume of the tree. Approximate formula for the volume of a cylindrical tree trunk, we're looking at pi times diameter over 2 squared times the height. Okay. So we've got the height is 155 feet and the diameter is approximately 8.27 feet. So what have we got? Pi, 3.14 times 8.27 divided by 2 squared. We're looking at 17 times 155, 15, 8,000, around 8,000, a bit more than 8,000 feet was 8,000, 300 cubic feet. 8,300 cubic feet. So now we convert this to board feet because we want to know how much material we've got here. So to convert cubic feet to board feet, we'll say that we have 1 cubic foot equals approximately 12 board feet. So now we want to convert this volume to board feet. And to convert cubic feet to board feet, we'll say that 1 cubic foot equals approximately 12 board feet. So, board feet is 8,300 times 12. We're looking at 100,000, approximately 100,000 board feet. So based on the size of this tree, we're looking at roughly 100,000 board feet of lumber. It's amazing. Now imagine what we can do with that. This is an entire warehouse worth of raw material just waiting to be put to work. Just imagine, we take this tree down, that's thousands of shipping pallets ready to be built, or enough wood to supply multiple construction projects. I mean, we're talking about lumber for crates, plywood, framing, flooring, whatever we need. So, a small house, 1,200 to 1,500 square feet, this is going to require 10,000 to 15,000 board feet. You're looking at 3 to 6 small houses. And here's the best part. Because cottonwood is so light and versatile, it's incredibly easy to process. We could have this wood cut and ready to go before you know it, feeding into all kinds of industries that rely on quick, efficient production. I mean, the economic potential is staggering. At current market prices, we're talking tens of thousands of dollars of value in lumber alone from just this one tree. And because it's cottonwood, we can replant in a few short years. We'll have another massive tree ready to harvest. So this isn't a one-time deal. It's a sustainable, renewable source of income that we can rely on cycle after cycle. But it doesn't stop there. Even the branches and offcuts can be turned into pulp for paper or biomass for energy. Every single part of this tree gets used. There's nothing wasted. I mean, we're talking about maximum efficiency from top to bottom, from root to crown. The moment we cut into this cottonwood, we unlock its full potential, 100,000 board feet of usable, profitable material. And that's the kind of opportunity that gets me fired up. So, the question is, now that I've told you about this tree, what's all of this got to do with technology?